Welcome back, everybody, to the fourth installment of QTM 200 Applied Regression Analysis. In this module, we're going to be talking about how to analyze and set up experiments, as well as what we need to do when things like our treatment or the covariate of interest that we have that we think explains a bunch of variation in our outcome. When that is not randomly assigned, then we need to think about dependencies between our variables. And we'll talk a little bit today about contingency tables. So as a brief summary of where we've been, remember the goal in the back of our heads is always that we're trying to make inferences about a given population from some data that we've collected. And last module, we talked about how to characterize a single variable in the sense that we are able to find a point estimate like a sample mean or a sample proportion, and we constructed confidence intervals around that point estimate in order to conduct a hypothesis test. Now we want to look at or compare more than one variable. We want to look at whether one variable, and we'll call that X as our main predictor, causes Y, our main outcome. There's two ways that we're going to talk about doing this today. We're going to compare two independent samples, and importantly, we'll talk about this as we move forward, but the requirement here is that there's some sort of randomization of a given treatment, and we'll be really harping on causality today and experimental design. The second way that we'll go about this is we can also estimate whether these two variables are dependent if we know that the data is coming from some sort of observational collection rather than a randomly assigned treatment. This is going to require us to learn how to do a chi-square test of independence, and we're going to focus on what exactly standardized residuals are. Essentially, the first kind of introduction that we're going to have into squared errors, and how that connects to regression analysis more generally. Now, as we move throughout the content today, I want you to keep in the back of your head that what we're really trying to achieve today is we're trying to start the seed of thinking about the data generating process, and not only how our variable of interest may affect an outcome, but also how other variables that may or may not be in our model is also affecting that direct relationship. And when we're talking today about comparing two different means of two different groups, we're going to be talking about an average treatment effect. So a very simple example of this would be in a medical trial where we have two different treatment groups. Both are going to receive a pill. Neither group knows what pill they're receiving, and the assignment is random, but one is going to be receiving a placebo and the other is the actual treatment, and we want to see whether or not that medication is efficacious. So we'll look at maybe whatever the outcome we're interested in. Maybe it's a blood pressure medication. We'll look at the mean blood pressure of the group that took the medication and the group that took the placebo. Now, we're also going to start to talk about when we don't have random assignment, and like I said, there are maybe some variables lurking either in our model that we've specified and need to think more carefully about the exact relationship it has, or maybe it's something that we've left out of our model, but something that's pre-treatment that's going to influence whether or not someone takes that medication and their blood pressure. So maybe education, right? Maybe people who have higher levels of education are more likely to follow instructions, and they'll be more likely to take the medication regardless of whether they're assigned to the treatment or placebo group. And again, we're going to start to talk about this in the context of contingency tables and determining dependence between two variables. And then in subsequent weeks, we'll move on to talking about bivariate regression, multivariate regression, and other types of generalized linear models that allow us to more specifically incorporate data dependencies in the data generating process.